All right, factor by grouping. So we're going to continue with what we left off with, still factoring. Uh, this is a continuation basically of the same thing we were doing, and I'll remind you what we were doing before and then move on to a leading coefficient, which changes things a little bit. So what we did is we took a look at the factors of a times c, which is 10. So it was factors of 10 that added up to 7, the middle number, right? And we know if we list them 1 times 10, 2 times 5 are all they're going to get. And since these are all positive, since these are all plus plus, and we know we're adding, and it's got to be 2 and 5, or 5 and 2, and it really doesn't matter. The factored by grouping method said y equals x squared plus 2x plus 5x plus 10. And notice that all I've done is I've rewritten 7x as 2x plus 5x. The grouping comes into play when I just group like this and factor out what I can factor out. So in this case, I'm going to factor out an x. That leaves an x plus 2. I'm going to factor out a plus 5. That leaves an x plus 2. And notice that those factors there are the same. Okay? So we're going to now regroup this and factor out the x plus 2's. If you factor those out, in other words, you pull them out, they're not there anymore, what's left? Okay, and what's left is the x plus 5, and you factored by grouping. Okay, next one. We have a leading coefficient, so now we got to multiply again. A times c is 4. So we're looking at factors of 4 that add up to 5. And you're going to list them. 1 times 4, 2 times 2, and obviously 2 plus 2 doesn't add up to 5. 1 plus 4 does. So this is going to be 1 and 4. So when I rewrite this, y equals 4x squared plus 1x plus 4x plus 1. And to be honest with you guys, you can switch the 1 and the 4 around if you want. We're looking for factors that we can factor out now. We got to group these. Okay, when we group, we pull out a common factor of x. That leaves a 4x plus 1. You have to pull something out, but there's nothing there. So what you pull out is a 1. When you pull 1 out, 1 doesn't change anything. 4x plus 1. And again, you're going to factor out the 4x plus 1, and what's left is x plus 1. 4x plus 1 comes out. If those come out, right, those are now gone. What's left? X plus 1. All right. So same process that you've been using, only we're adding the leading coefficient. I'll do one more. I don't know if I need to do both of these. Same thing, factors of 2 times 3. Actually, number 8 gets bigger numbers. Let's do that. Well, maybe I'll post it for you. All right, so let's do 7. 2 times 3 is 6. We're looking for factors of 6 that add up to 5. 1 times 6, 2 times 3. There aren't any more. So 2 and 3 are what we got. Y equals 3x squared plus 2x plus 3x plus 2. Group and factor if you can. Pull out an x, leaves a 3x plus 2. You have to pull something out. In this case, you'll pull out a 1. That leaves a 3x plus 2. Regroup and pull out that 3x plus 2. What's left is the x plus 1. Okay, so number 8, just to give you an idea what's going on here, 5 times 4, right, is 20. So we're looking for factors of 20 that add up to 12. And this can be a little more challenging, right? 1 times 20, 2 times 10, 3 times 4, not 3 times 4, 4 times 5, hello. 4 times 5, and clearly the 2 and the 10 are what add up to 12. 2 and 10. So I'm going to stop. I'll finish it and let you see it. Okay, so number 8, if you need to pause the video and look at it a little bit closer, that's the idea. All right. We move on to looking for the greatest common factor, and I'm not going to do this problem, but clearly if you pull out a 2, it makes factoring a little bit easier, possibly. Then they go on and say, well, wait a minute, you don't actually have to factor out the greatest common factor. You could do it this way. The question is, which way is easier? Is it easier to work with smaller numbers or bigger numbers? And that's up to you. I'm going to let you look at that and play with that as needed. All right. So I am going to give you some couple of practice problems to work on. Number 12, factor it out so it's a leading coefficient. Factor out a negative leading coefficient so you can work that one. Go ahead and pause the video and I'll show you the answers. Okay, so I'll let you pause the video and check these out, make sure things are correct. There was a mistake. There's a typo here. That should have been a plus in order for this to work out. Anyway, like I said, I'll let you take a look at that on your own time. You can try one of these or both of these if you will. I'll go ahead and work them out and leave you with the answers. All right, again, I'll let you pause this and take a look at it all you want. See if you understand what we're doing. Factor by grouping. We need to have the process down. Okay, and then the last two problems are just asking you to find out what you know. Okay, so number 16, factors of 15 that add up to 8 are going to be 5 and 3. So x plus 5, x plus 3. We know the x-intercepts then are negative 5 and negative 3. Y-intercept of 15. The negative 5, negative 3 come from here. The 15 comes from here. The vertex, a couple ways you can do this. We know the axis, x equals negative b over 2a, so that's going to equal negative 8 over 2 or negative 4. And then we plug that in and go f of negative 4 gives us 16 minus 32 plus 15 equals negative 1. So when we plot this, we've got negative 4, negative 1. You've got a y-intercept at 15 here. Up 1 over 1 turns out to be those are our x-intercepts. And there's your parabola. We missed the point, didn't we? That one I hit. And then number 17, I'll let you try. I'm going to pause it and give you a chance. Then I'll just give you the answer. All right. And again, I'll let you pause this if you want to analyze this a little bit more. factor by grouping. Good luck.